Okay, a soap bubble appears green, lambda equal to 540 nanometer at the point of its front surface nearest to the viewer. What is the smallest thickness a soap bubble film could have? Okay, assuming the refractive index of the bubble is 1.35. Okay, so this is about what question is this? Single slit, double slit, thin film. Yeah, so look at here. He said about soap bubble. Yeah, film. This soap bubble is a film. So this definitely about thin film. Okay, thin film questions. Okay, and then this one is which kind of thin film? Okay, is it the low higher highest or low higher lower refractive index? What I can say is it about in phase source or is it anti-phase source? Okay, is it non-reflective coating or reflective coating? Is it the reflected light has no phase difference or the reflected light has phase difference of pi radian? So this is yeah, what I'm saying just now about low, higher, and highest. That is about the refractive index. Yeah, like this one you see, low, higher, highest refractive index. And this one is low, higher, lower refractive index. So which one it belongs to? Okay, so this soap bubble, of course, is about this one, low, higher, lower, air, soap bubble, and then air again. This one, right, is referred to this one. So maybe I can draw it out. Okay, I can draw it out and see. Okay, this is the thin film, or I can say the soap bubble. Yeah, let me highlight it. This is the thin film, the soap bubble. Okay, so outside of course air, inside also air. All right, and then this one is the soap bubble. The soap bubble is the film. Yeah, it's the film. Okay, so refractive index, this one is n equal to 1, this one is n equal to 1.35, and this one is n equal to 1. So you must draw like this. Yeah, so it's low, this one is referred to low, higher, and then low, back to low again, low refractive index. Okay, now I want you to draw the ray. Yeah, the ray coming from the air. Okay, and then see how many times phase change it happens. Yeah, so before we draw this ray, yeah, so remember this rule. Yeah, remember this rule. Phase change of pi radian, yeah, phase change of pi radian only happens for reflection. Reflection only. Not refraction, don't have. Yeah, only reflection. Okay, and also only from lower to higher refractive index. Only from lower to higher refractive index. So you can see this one. When it happened, the pi radian phase change only happen for reflection from lower to higher refractive index, like this one. You see that? Here you can see 4 conditions. Only this one got phase change of pi radian. You see that? That is reflection from lower to higher refractive index, got pi radian phase change. And then the light that go inside, the refraction, no phase change. And then same thing goes to this one, reflection from higher to lower refractive index, no phase change. And then the refraction from here to here, the refraction also no phase change. So phase change only happens here. This is what? This is reflection from lower to higher refractive index. If from higher to lower refractive index, reflection, no phase change. Okay, remember that. So okay, so go back to this one. So okay, the first ray comes, and then one ray reflected, one ray reflected, another one ray reflected. Okay, talking about this one, this one is reflection from lower to higher refractive index. From low to higher refractive index. So this one definitely got phase change. This one got phase change of pi radian. Okay, this is the first ray. This is the first ray. Okay, now the second ray goes into the film. The one goes into the film, no phase change. Yeah, as we know, refraction, no phase change. Now reflection, got phase change. For this case, here got phase change. This one is from higher 1.35 to 1, 1.35 to 1, higher to lower refractive index. Reflection got phase change? No phase change, because this one is from higher to lower, not from lower to higher. Understand? It is from higher refractive index to lower refractive index. From the soap bubble to air. Air is a lower refractive index. So from higher to lower refractive index, reflection, no phase change. And then the light also go out. The light also go out like that. Also no phase change. Refraction, no phase change. So for the second ray, for this second ray, okay, the second ray is reflection from higher to lower refractive index. Higher to lower refractive index, no phase change. No understand? Phase change. All right. Okay, so this one is reflection from higher to lower refractive index, no phase change. No phase change. Okay, but for the first ray is from lower to higher refractive index, reflection got phase change. Understand? So okay, so you can see ray 1 got phase change 5 radian, second ray no phase change 0 radian. So what is the phase difference? What's the phase difference between these two rays? So let's find out. So the phase difference delta phi between these two rays is pi minus 0. Pi minus 0 equal to pi radian. So these two rays got pi radian difference. Understand? These two rays got pi radian phase difference. So these two rays got phase difference of pi radian. So they become anti-phase. So they become what? Two anti-phase sources of light. They become anti-phase. So this ray 1 and ray 2, they got pi radian phase change. Yeah, I mean they got pi radian phase difference. Yeah, so they are anti-phase. They're anti-phase. Yeah, so it's belong to this one. Ray 1 and ray 2 got pi radian difference. So that means got pi radian difference means got they are anti-phase. They're anti-phase. Yeah, two anti-phase sources. Okay. So anti-phase sources. Okay, so what's the formula for anti-phase sources? Bright fringe formula and dark fringe formula. Still remember? If anti-phase, go back to the concept. Yeah, to the earliest concept, which is this one. Remember this one? If two in-phase sources, the bright fringe is m lambda. The bright fringe is using m lambda. Dark fringe is m plus half lambda. But anti-phase source, if two anti-phase source, the bright fringe become m plus half lambda. And then dark fringe become m lambda. The formula interchange. You see that? Anti-phase become m. For two anti-phase sources, the bright fringe becomes m plus half lambda, which normally use m lambda. Now become m plus half lambda. And then you can see go to this one. Two anti-phase sources. That's why you can see the formula bright fringe is using m plus half lambda. Dark fringe use m lambda. See, interchange already. Interchange already formula. Compared to last time, bright fringe use m lambda. For two in-phase sources, breadth fringe use m lambda. This time the two anti-phase sources, the breadth fringe use m plus half lambda. See that? So that's the formula to anti-phase sources. The formula become interchange. Is 2nt equal to m plus half lambda. And then dark fringe use n lambda. Okay? Two anti-phase sources, so that's the difference. The bright fringe become m plus half, the dark fringe use m lambda. Okay? And then one more thing you need to know is about the order. The order, which one? The bright fringe and dark fringe. Dark fringe must start from 1. The order must start from 1. Okay, I must write beside here. Okay. The order, talking about the order. I want to write, where should I write? Okay, let me write. Okay, so bright fringe, for bright fringe, the order start from 0, can start from 0. It can start from 0, 1, 2, and so on. Alright, but for dark fringe, the order cannot start from 0. The order must start from 1. Yeah, it cannot start. The order cannot start from 0. Okay, the order cannot start from 0. This one can start from 0, but okay, this one can start from 0. This one, bright fringe, the formula, the order can start from 0 because it still got half lambda here. You see that? Because if even you put the order equal to 0, the thickness still got half lambda. So the thickness is not 0. Thickness is not 0. So the thickness of the film is not 0. So it's possible. Okay, so this one order can start from 0 because you still have the thickness of thin film. Okay, so it's still I can say feasible. Still can do it. Yeah, if order is 0, you still have thickness of thin film, so it's still correct. Okay, but for this dark fringe, if you put order equal to 0, then the thickness also becomes 0, which is not possible. Thickness cannot be cannot be equal to 0. Yeah, thickness cannot be 0. Because if the thickness becomes 0, if the thickness of thin film becomes 0, that means you have no thin film. Like you have thin film with 0 thickness. Like no thin film. So it's not possible. You cannot put order equal to 0. The thickness cannot be equal to 0. Understand? So the lowest is start from 1. The lowest is start from 1. Yeah, for this one. Okay, so just want to rub this off. Right. So this order must start from 1 lah. This order must start from 1. Yeah, cannot start from 0. Okay. So I already explained about that in my lecture video. Actually, this one I already explained in my lecture video. The dark fringe one, the thickness cannot be 0, so the minimum order should be equal to 1. Yeah. For bright fringe, the minimum order of the minimum m value can be equal to 0 because it still have half lambda, so the thickness is not 0 yet. Okay. So this one order start from 0, this one order start from 1, and that's it. Yeah. This bright fringe formula, the order start from 0. Dark fringe formula, the order must start from 1. Okay, it must start from 1. This one start from 0. This one is start from 1. That's it. Okay. Okay. Now go back to this question. What is the smallest thickness? Oh, so this question asks for smallest thickness. That means thickness minimum. I want to get thickness minimum. Okay, this one use bright fringe or dark fringe? Which one? Which one you use? You use bright fringe or dark fringe? What is the clue here? The clue is over here. See that? The clue is over here. Appears green. Appears green. So it looks very bright in green color. Very bright in green color. So this is a bright fringe. Understand? This appears green. That means it means you can see the green color. Yeah, appears green. Appears green. That means this have a green bright fringe. Has a green bright fringe. Has a green bright fringe. Appears green means green bright fringe. So we're going to use this formula. We're going to use this one. Okay. We're going to use this one. Understand? Okay, we're going to use this one, the bright fringe formula. All right. So let's do it. Let's continue. So we're going to use the bright fringe formula, which is two anti-phase sources. Two anti-phase sources, which is 2nt equal to m plus half lambda. Okay. So minimum thickness means the thickness is the smallest. So the order also need to be smallest. What I can say is if minimum thickness, okay, if minimum thickness, that means if you want minimum thickness, that means the order also minimum. The order also minimum. So the minimum order allowed for this formula is 0. Can be 0. It can be 0. But if dark fringe, the minimum order is 1, cannot be 0, because the thickness cannot be 0. The thickness of thin film cannot be 0. Okay. This one, if minimum order for dark fringe, you must start from 1. You must put m equal to 1 if you're using the dark fringe formula m lambda. Okay. But for bright fringe formula, got plus, because got plus half lambda. So the minimum order for this one, you can put 0. Okay. So okay, now I know that m must put 0. And then what else? The n value is 1.35. Okay, so I got the n 1.35. And then order put 0. Lambda is 540 nanometer. Okay, so I have everything, every value. Okay, so n use the soap bubble refractive index 1.35. Okay, use this one. Remember, use this one, soap bubble, 1.35, and then minimum thickness equal to this one is 0. Okay, 0, then plus half. Lambda is 540. I think you can just maintain nanometer. So later on, your thickness also in nanometer. Yeah, your thickness also in nanometer. So let's calculate, yeah, your thickness, your minimum thickness of thin film. Okay, so 540 multiply half, okay, and then divide by 2, divide by 1.35 again. So the answer is 100. The 100 nanometer. 100 nanometer is also, you know, this one is exponent negative 9 meter. So at last you get the answer is 1 exponent negative 7 meter, or 100 nanometer. Okay, so is the answer correct? 1 exponent negative 7 meter, 1 exponent negative 7 meter, that's correct. Yeah, or 100 nanometer, that's correct. Okay, so that's it for these questions. So the key is you just look at, this is about thin film. So it's about low, higher, lower, refractive index, then got only one time phase change, one ray only phase change, the other ray no phase change. So got phase difference between them, pi radian, so become anti-phase, and then anti-phase formula, bright fringe use m plus half lambda, dark fringe use m lambda. And then this question says about using you know, this formula is about this question is about appears green. Appears green means bright fringe in green color. The bright fringe in green color. So we're going to use the bright fringe formula. All right. And then minimum thickness. Minimum thickness means the order also need to be minimum. So this formula allows minimum order of 0. Okay, unless if m lambda, then the minimum order should be 1. Okay, minimum order should be 1. So okay, this one m equal to 0. So you just put everything inside and get a minimum thickness. That's all for these questions. Okay, bye.